My dear students, today I am going to teach a important lesson, language of chemistry. This is very important and basic chapter in the study of chemistry. Now, in this sequence, I will first define radical. Now, the radical. My dear student, you have to understand the radicals. Radical is a atom or a group of atom which have positive or negative charge on them and behave as a single unit through series of a chemical reaction. Understand? So I am going to tell you some example of radicals. First I will give the electronegative radicals. In electronegative radicals, just I am going to tell carbonate CO3 and radical charge is denoted by writing on above the carbonate radical. So carbonate radical has two negative charge. And another example of radical is sulfate, SO4. SO4 has charge of -2 unit, and it is written as like this, -2 unit. These are radicals, and radicals behave as a single unit in a chemical reaction. Another bicarbonate HCO3 -1 charge. These are the radicals. Bisulfate HSO4. This also has -1 charge. All these are electronegative radicals. And you are saying these are made up of group of atom. Carbonate radical is made up of carbon atom and oxygen atom, and have two unit negative charge. Sulfate radical is made up of sulfur and 4 oxygen atom and have -2 unit charge. Bicarbonate radical, it is made up of hydrogen, carbon and 3 atom of oxygen and have 1 unit minus charge. Sulfate radical is made up of hydrogen, sulfur and 4 atom of oxygen and have 1 unit minus charge. And in negative, you can also oxide radicals. It has 2 unit minus charge. Oxide radicals, ferrous radical, Fe. It has ferrous positive. Chloride radical, Cl. It has -1 unit charge. These all are electronegative radicals. It means all the ions, group of atoms having negative charge on them. For this they are known as the electronegative radicals. And my dear students, you are observing that, as I told, radicals are atom or group of atom having positive or negative charge on them, and you are seeing in these radicals atoms. Oxygen is simply atom, chlorine is simple atom, but having 2 unit minus charge and this 1 unit negative charge. And in the rest you are seeing they are made up of group of atoms and also having charges on them. And all these radicals, all these ions have negative charge. Very clearly, all of you are seeing, all are having negative charge. For having negative charge, all are known as the electronegative radicals. Understand? All are known as the electronegative radicals. Negative radicals. All are known as electronegative radicals. In the same way, atoms are group of atoms having positive charge on them. They are known as electropositive radicals. I am going to give you some example of electropositive radicals. In the electropositive radicals, ammonium NH4, it has 1 positive charge. This is the electropositive radicals. It is made up of group of atoms. In this group of atom there is nitrogen and 4 atom of hydrogen. You are seeing 4 atom of hydrogen and having 1 plus unit charge. Another electropositive radical, ferrous radical, Fe2 plus ferrous radical. Another positive radical, Fe3 plus, ferric radical. This is an ammonium radical. This is a ferrous radical. This is the ferric radical. Another Cu plus 1 charge, cuprous radical. Another Cu plus 2 unit charge, having plus 2 unit charge. This is a cupric radical, and so on. If atoms or group of atoms have positive charge on them and behave as a single unit in a different chemical reactions, will be called radicals. And these are having positive charge, so they are known as a electropositive radicals. These radicals are very important, and you are suggested to prepare electronegative as well as electropositive radical, because these radicals are very important to write the formula of any compounds. If you have not learnt these radicals, you cannot write the chemical formula of any compounds. For this reasons, my dear students, you all requested to prepare electronegative and electropositive radicals. These are electropositive radicals. It means positive radical. Positive radicals. Radicals. These are positive radicals. Now, I am going to tell you how these radicals are important while writing formula of any chemical compounds. Just writing writing formula of some compounds by using these radicals. My dear students, all of you know how these radicals are important. Just I am going to give you examples. If you have to write, suppose the formula of calcium carbonate, how you will write this? For writing, first you will write radical side by side. First write positive radical, then write negative radical. In writing the formula of calcium carbonate, calcium carbonate. We write first positive radical as a calcium radical and negative radical as a carbonate radical, side by side. Now you see here, first we write calcium radical. This calcium radical, 2 Ca, again 2 positive charge. Carbonate radical, CO3, have 2 unit negative charge. This. First you will write like this. Then after you will cross multiply it. These charges, it means this carbonate charge, it means balancing 2 irrespective of charge. This 2 will come to below calcium in small size, in small case, and this will just come carbonate right side in small case. For this we will write like this. This 2 will come to here and this will come to here. Because this is a group of atoms, so we will multiply this carbonate radical by 2 by taking a bracket, and this radical is made up of only one atom. So we don't need the bracket. Now this will be like this. Ca, this to come to below Ca in small case, Ca2, and this 2 will come to the carbonate side, right side of the carbonate, CO3, and this carbonate radical is made up of group of atoms, so we will take the bracket like this, and then after we write the number of charges. And we are not writing the plus and minus in this because molecule is electrically neutral. Any molecule of compounds have no charge because total charge is 0. It means 2 unit positive charge and 2 unit negative charge. Just on addition becomes 0. So on the molecule the net charge just be 0. So we avoid writing the charges on the molecules. So this becomes Ca2 in bracket CO3 twice. Now this balance is equal. So we will simplify this by taking highest common factor is 2. So this 2 is divided by 2. So this 2 on the 2, just 2 on the 2 and this 2 on the 2. By taking highest common factor, this will be divided by 2. So 2 on the 2, we divide this 2 by 2. So 2 on the 2. So I write the 1. Or this also 2 on the 2. I write 1. And on simplifying, just 1 is not written as it is understood. 1 is multiplied in all the number. So it will like this: CaCO3. CaCO3. This is the final formula of calcium carbonate, CaCO3. Just I am going to tell this by taking another example. Another example. Magnesium carbonate. Magnesium chloride. Mg magnesium chloride. Magnesium chloride. My dear student, you have to understand how the formula of magnesium chloride will be written. Understand? Already I have told the radicals will be written side by side. First we write the positive radical, then we write the negative radical. In magnesium chloride there are two radicals, magnesium and chloride. First we will write magnesium radical, then after I will write chloride radical. Then again we will do the method of crisscross. It means the balancing will be interchanged and will be written downside of the radical in small case. First say this examples, you will easily understand. I am going to write the formula of magnesium chloride. So then first we write the magnesium radical Mg, and magnesium radical is Mg2 plus, and chloride radical, then chloride radical Cl minus 1. Now we will cross multiply these. This one will come to and downside of magnesium, and this 2 will come to downside of the chloride radicals. Then it becomes Mg1, and 1 is always not written because each number is always understood multiplied with 1. Here now it will become like this. mg, this one come to this one come to the downside of the mj. One will be not written because 1 is understood as factor of any number, any digit. So 1 always be factors. So 1 is not written, and this 2 will be written downside of chlorine in a small case. MgCl2. And the final formula of magnesium chloride will be MgCl2. And the writing method of formula in this way is known as a crisscross method. Understand? So, I guess you have understood how the formula of any compound, means calcium magnesium chloride, is written here. MgCl2. If we take another example, suppose we take example of sodium chloride, common salt, sodium chloride. This sodium chloride is very commonly known as a common salt because sodium chloride is found in each and every houses. For this reason, sodium chloride is also known as a common salt. I will tell you how you will write the formula of sodium chloride. Understand? So in this way, writing the formula of sodium chloride, first you will write the sodium radical, that is electropositive, and chloride radicals, that is electronegative, side by side. Already I told. First we write positive radical, then after we write negative radicals. Now I write positive radical, sodium Na. All of you are understand the sodium radical is Na plus 1 and chloride radical is Cl1 minus. And then we do the crisscross method. This one will come to here and this one will come to here. It is below the chlorine. And after this we get NaCl. Na one is not written and below the one is not written below the Na and one is not written below the Cl. Finally it becomes NaCl. I wish my dear students, all of you have understood the writing formula of compound sodium chloride. NaCl. This is the common salt. Another example I just am going to take. Sorry. Another example. Potassium dichromate. Other examples I take potassium dichromate. Potassium dichromate. For writing the formula of potassium dichromate, first of all you have to know the radical potassium and electropositive radical and radical dichromate electronegative, and you will write these radicals side by side. Potassium radical is K1 plus, dichromate radical Cr2O7. This is the dichromate radical, and this has got 2 unit charges. 2 unit charges. As I have written in previous examples, likewise you can also, by adopting the method of Kriss-Cross, you can also write the formula of potassium dichromate. Here this 2 will come to the downside of the potassium atom, and this one will come to the downside of the dichromate radical. And this 2 will come to here, and this one come to dichromate radicals downside in a small case. So in this way we get K2. This 2 will come to downside of the K2. This 2 comes into downside K. So K2. Or this one come to dichromate radical, downside of the dichromate. But one always is understood the factor of everything. So one will be not written. So this will be the Cr2O7. This becomes formula of potassium dichromate, K2Cr2O7. So my dear students, I hope that all of you have